So now that we understand kind of the theory behind excise taxes in terms of, shifting the demand or supply curve, or it turns out not really mattering which one of those shifts, but it's creating this tax wedge. And instead of just kind of labeling them with, PS and PB, we could actually solve for the price the buyers pay and the price the sellers get using algebra. Just like we did when we solved for the simple equilibriums in supply and demand. So let's imagine, let's do an example to kind of see how we would do this. So let's look at the gasoline market. And let's imagine, we're going to use, the units we're going to use are millions of liters a month, so liters a month, millions of liters a month, and that's going to be our quantity. And then our price is going to be in cents. So that's the price. And let's imagine that our demand curve, these numbers might not exactly work out to be realistic, but we can kind of see how it works. So let's imagine the demand curve can be represented by this equation. Now we have price on the left-hand side. We saw quantity before, but this is just rearranging that equation. Is equal to 80 minus 5 times the quantity demanded. So we have this negative relationship, just like we did before, between price and quantity demanded, right? That's that law of demand. And then we can have our supply curve, or let's suppose our supply curve, price equals 24 plus 2QS. So we can see the positive coefficient in front of QS, which is indicating a positive relationship because of this law of supply. And so if you remember how we solve for equilibrium in kind of the simple equilibrium is by setting these two equations equal to each other to see where they cross. Before we had, QD on the left-hand side and QS on the left-hand side. But it doesn't really matter, right? We're just still solving for where these two lines equal each other and cross. So we can invoke equilibrium. That's where QS equals QD, or it's the price where that's true as well. So in essence, we're setting these two equations equal to each other in either case. So we have 24 plus 2QS equals 80 minus 5QD. But what I'm going to do is I'm going to take those superscripts out and just put a star, because we're actually solving for equilibrium because we've invoked it right there. All right, then we just have a simple rearranging here to solve for that quantity. And so we can take this 5Q and move it over, and we get 7Q star equals 80 minus 24, which is 56. So Q star is going to be equal to 8 here, right? So 8 million liters a month. Then we can figure out what our price is by plugging this Q star back into either one of these supply or demand curves, right? Doesn't matter which one. P star equals 24 plus 2 times Q star. We'll just do it in a couple steps. So P star equals 24 plus 16 equals 40. If my math is right here. Always questionable. All right, so that's what our equilibrium looks like. So I'm not going to draw kind of this to scale, I guess, but let's just visually think about what we're trying to do. So this is the supply curve here. It's like 20 or around there. 80 for our demand curve, and it goes down. Here's our demand curve, and we're just solving, if I can get this pen out, that this is equal to 8 and this is equal to 40. The price is 40 cents a liter. Nice and cheap gas, apparently. Okay, so now let's think about what happens to this market if there's a 14-cent tax on gas. And again, I'm not even talking about if it's on buyers or sellers, because it doesn't matter. It's a 14-cent tax on gas, right? So it's going to cause this tax wedge of 14 cents between buyers and sellers. So let's take a look. All right, so let's continue our example. Example continued. And so now we're thinking about what happens if there's a 14-cent tax. 14-cent tax on gas. All right, so let's, again, write out our demand and supply curves. But now instead of just putting, so this is the demand curve here. Instead of just putting P there, I'm going to say the price the buyers pay, right? Because that's the price the buyers pay and the price the sellers get is different with this tax. It's too big of a space there. I'll put an arrow. So PB equals, if we remember it, it's 80 minus 5QD. The supply curve was, again, now it's PS, the price the sellers get, was 24 plus 2QS. So we have two equations, but we're going to have one quantity, but we're going to have two prices. So we need one more equation. And the key here is realizing that the difference between the two prices is equal to the tax. So PB minus 14 equals PS. So this is using this idea that PB minus the tax equals PS. So if we draw, so we have an idea of what we're doing here. Remember we had, wish I didn't erase it now, our demand curve and our supply curve here, equilibrium of 8 million liters per month. I forget what the price was, 40 cents, I think it was, a liter in equilibrium. And so what we're doing here is putting a tax wedge of 14 cents. So this is 14 since the price is in cents, so don't let that confuse you. That's why it's 14, not 0.14. And the top of this wedge is the PB and the bottom is the PS, right? The price the sellers pay. So the difference is equal to the tax. So we're just saying the price the sellers pay, or sorry, the sellers get is equal to the price the buyers pay minus that tax. So that's how we're getting this third identity. And now we have three equations and three unknowns. So we can algebraically solve for this new quantity, equilibrium quantity, as well as these two prices. All right, so let's call this equation 1, equation 2, and equation 3. Three equations, three unknowns. We can do this. So the first thing we're going to do is sub 3 into 2. So we know that this is the supply curve. PS equals 24 plus 2QS. We also know that this PB minus 14 equals PS. So we can sub this identity for PS in there. So we get something like this, right? Because this is, we just said that this is PS. Just using that identity over here. It's always going to be true. All right, so then we can just rearrange, and now we can get PB, this is our supply curve we're dealing with. PB equals, moving the 14 to the other side, is 38 plus 2QS. And let's call this equation 2 prime or something like that. That's like our supply curve, but now we've kind of put the buyer's price into our supply curve. And now we can invoke equilibrium. So the supply curve equals the demand curve is all I'm trying to say here. We can invoke equilibrium by setting 2 prime equal that first equation. The demand curve equals the supply curve, right where they cross. So we're figuring out where they cross, and then that will allow us to figure out what this price the buyers pay is, or the quantity, and we can start figuring out all the different identities. All right, so let's take a look. I'm going to quickly erase this because we got to do some algebra. All right, so I just rewrote the equations up here so we could remember what they are, and then we invoked equilibrium, right? So we set these two equations equal because that was kind of the equivalent of saying QS equals QD. Is 2 prime equals 1. And so what we get is 38 plus 2Q, and I'm just going to put Q there because we're invoked equilibrium, equals 80 minus 5Q. So again, we could move this 5Q minus 5Q over to get 7Q equals 80 minus 38 is 42. So now Q star equals 6. So notice that quantity has gone down in equilibrium now. It used to be 8 million liters a month or whatever it was. Now it's 6. We know the quantity. We can figure out now PB. 38 plus 2 times Q. So PB equals 38 plus 2 times 6. 12 is 50. So this is the price the sellers get. So we just took our quantity and plugged into either of these two equations to get the price the buyers pay. So 50 cents a liter now. And now we can figure out, we can use that third identity we talked about before. PB minus PS equals the tax. So that means 50 minus PS equals 14. Well, we know it needs to be the difference, so 36. So let's draw out what this looks like graphically. So now we solved for all the elements, but let's make sure we understand what we did. So here's our demand curve that started at 80. Here's our upward sloping supply curve. Again, this is not to scale, so the actual, you can see the burden is going to the buyer, so the demand curve should be relatively more inelastic. We had an original quantity of 8 million liters a month and a price of 40, I believe. Then the government came along and put this 14-cent tax wedge in. We figured out the equilibrium quantity now is 6, so went down there. Figure out the price that the buyers paid was now 50 cents a liter. So 10 cents is buyer's burden. Hopefully you can somewhat read that. The bottom of this wedge is the price the sellers get. We just figured out that was 36. This is 4 cents in seller's burden. And we've kind of algebraically solved for all the elements, PB, PS, and the new quantity. So that's how the algebra of excise taxes works.